All right, good day everyone. Today I'll be teaching you how to calculate pH calculator. This is very useful to many of our students, especially those ones that are writing exams with sophisticated calculators. Example, the UTME exams examination, where some other sophisticated examination, like the WAEC, where the calculators are very sophisticated. So now, how do you calculate pH? Now, first, basically, this concept is for the pH of a strong acid or base. pH of a strong acid or base. Now, first, we have this question here. So, before we look at the question, what's pH concept? Now, pH is a negative logarithm of hydrogen ion to base 10. The pH was actually devised, or the concept was devised by Soren Sorensen. Soren Sorensen many years ago. It's a measure of acidity and alkalinity of a substance. So, pH basically, for calculation purpose, let's first as a formula of negative logarithm of hydrogen ion to base 10. Now, this formula works for strong acids and strong base. Also, the reverse of pH is pOH. pOH is negative logarithm of hydroxy ion to base 10. That's for pOH. Now, having known that basically, having known that pH plus pOH equals to 14. And another concept you have to know is that hydrogen ion times hydroxy ion is equals to 10 raised to power minus 14. Now, basically, remember the video is how to calculate the pH of a substance, especially for a strong acid and strong base, without a calculator. Now, first, what you have to just do is that you need a calculator to solve this. Also, you need a calculator to solve this. You need a calculator to solve that. You need a calculator to solve this. Now, what you have to just simply do is very simple. When you are given a question on pH, we are given a question on pH, what you do is simple. Now, try to make the hydrogen ion concentration, try to place it in standard form, in something like this. When you place the hydrogen ion in standard form, therefore, n minus log A. So in standard form, it should not be A times 10 to the power minus n, minus 5. So n is the, what's it called, the power. So n minus log A will give us the pH of the solution. And what you have to not just do, the only thing you have to count is log 1 to 9. Log 1 is 0, log 2 is 0.30. Just memorize it, can do that. Log 3 is 0.477, log 4 is 0.602, log 5 is 0.699, log 6 is 0.778, log 7 is 0.845, log 9 is 0.903, log 8 is 0.903, log 9 is 0.954. So memorize the logs of 1 to 9, then you'll be able to solve these questions. Okay, now first let's apply, because application is key. Application is key. Remember, put your hydrogen ion or hydrogen ion in standard form. Therefore, your pH or pOH should be something like this. Now, first, we have a question now. We have a question which says, what is the pH of a 2.5 times 10 to the power minus 3 molar solution, that's 1.0 GMP concentration of NaOH? Now, NaOH first, we can get pOH from NaOH. Why can we get pOH from NaOH? Why do we get pH from NaOH? Because it is a base, and NaOH contains OH. There's no hydrogen ion there. So it's a base and it contains OH. There are no hydrogen ion in NaOH. There are no hydrogen ion there. So quickly, to get the hydroxy ion concentration, what we can obtain is the hydroxy ion concentration. To get the hydroxy ion concentration for NaOH, we are going to take the concentration of the solution and multiply it with the number of OH in the compound. In this compound, there is just one OH. So therefore, the OH ion concentration is 2.5 times 10 to the power minus 3 times 1. That's how you get it. So even in for acid solution, if you have to get the hydrogen ion, you take the hydrogen ion concentration of the, or rather the concentration of the compound, and multiply the number of hydrogen present. I'm going to solve more questions. So you observe. Now, 2.5 times 10 to the power minus 3 times 1, because there's one OH. That will give us the hydrogen ion concentration, which is also equals to 2.5 times 10 raised to power minus 3. So that is the OH ion concentration. Now, what we cannot get is POH. Now, quickly, remember or recall quickly that if, recall please, that if OH ion concentration is equals to 2.5 times 10 raised to power minus 3. Therefore, POH should, remember this is synonymous. This is synonymous to, what's it called? A times 10 raised to power minus n. Very synonymous. So therefore, POH should be more or like n minus log A. So what do we do? So POH is therefore n is 3 minus log 2.5. So we can put this in a more better standard form so that it will be very easier. So we have a whole number instead of a decimal, because we don't have whole number and log. So we don't know that. So what you just put it in whole number. So this thing is mathematics, read your mathematics. 2.5 times 10 to the power minus 3 is as 25 times 10 raised to the power minus 4. It's the same as 25 times 10 to the power minus 4. Yes, 25, because 25 is equals to 2.5 is equals to 25 times 10 raised to the power minus 1. So divided by 10. So it's more like that. So quickly, we will now have, what's our n now? Our n is 4 minus log 25. 4 minus log 25. So, and I would like to say this. Now, I would like to say this. Now, what would I like to say? I would like to put it here. Log AB is the same thing as log A plus log B. Log AB is similar. This is a logarithm is equals to log A plus log B. Log AB is equals to log A. So log 25 should be, this PO should therefore be equals to 4 minus, in brackets, log 5 plus log 5. Because 25 is 5 times 5. Yes, 25 is 5 times 5. So 5 plus, so log 5 plus log 5. So we are broken it down still to this process without a calculator. I only have to just know this. So therefore, what's my POH? My POH, remember we're still on POH. My POH is therefore now equal to 4 minus 0.69 plus 0.69. 4 minus 0.69 plus 0.69. That's my POH. 4 minus 0.69, 0.69. Okay, that should be, now, so if you use your calculator, now you can use your calculator to do it from here. So the pH is therefore equals to, because you will be given a sophisticated calculator, but remember 1.3, you guys, if you get 1.3 0.693, so I need, let me need space, let me do simple mathematics. So let me just work here of my simple maths. So therefore, I have from there, I have 0.693 plus 0.693. So that should be 6. 9 plus 9 is 18. Put 8, take down 1. 6, 12. 12. So we add 1 to it, that's 13. So carry that one there. So 1.386. So you have 1.386. Add that to, therefore 4.000 minus 1.386. That's what I'm doing. So I'll have quickly, this is like, you take 1 from here, yes, 3, yes, 10, now 9. If you borrow 1 from here, take, it'll be 10. Now borrow 1 from here to be 9. Borrow 1, then take 1 here to be 10. Borrow, take 1 here to be 10 minus 6 is 4. 9 minus 8 is 1. 9 minus 3 is 9 minus 3 is 9 minus 3 is 8. 3 minus 1 is 2. So I just did simple maths, 4.000 minus this mass simple addition. I'll get 2.614. So the pH is 2.614 without a calculator. Without a calculator. I've done this without a calculator. As simple as that. Remember, they asked us for pH. They did not ask us for pOH. They asked us for pH. They asked us for pH. They didn't ask us for pOH. Now, remember, I said earlier, pH. You can take the video back if you don't, if I've cleaned the concept. Now, pH plus pOH. Remember, I said is equals to 14. Therefore, you can say that the pH now equals to 14 minus pOH. Still on that question. So what therefore pH is therefore 14 minus 2.614. So 14 minus 2.614. You can also do that in the substitute 2.614. Okay, so therefore here will be 10. I've already gone from here. Here will be 3 now. Here will be 9. Here will be 9. You know what I did now? 10 minus 4 is 6. 9 minus 1 is 8. 9 minus 6 is 3. And 3 minus 2 is 1. So I have 11.36. So therefore, the pH is equal to 11.386. That's a simple answer. We solved without a calculator. So the pH of soda, concentration of sodium hydroxide is 11.36. 11.36. Now, the next question I will have to drop now. I have to drop the next question. It's very kind of tricky and easy. Tricky and easy. So simple, very simple. So I have to drop the next question. The next question. So I'll have to wipe it off. The next question. Another question. It's quite simple. You can pause the video, read the video anywhere you are confused. So it says, what is the pH? What is the pH of 0.001 mole per dm cube? Mole, okay, put it somewhere like 0.001 mole per dm cube. What is the pH of 0.001 mole per dm cube of H2SO4 solution? H2SO4 H2SO4 solution. So very simple, very simple, very simple. So first we said these formulas are to calculate the pH of strong acids. So when we talk about weak acids such as ethanoic acid, formulas are not necessarily used. They are not used, not necessarily used. So not used. So pH of so when you have for acids, pH is minus log hydrogen ion to base 10. Now this acid has hydrogen, so you can produce hydrogen ion. So as I said earlier, to get hydrogen ion concentration, for this acid, to multiply the concentration of the compound, the whole compound times the number. How many hydrogen is there? 2, H2 times 2. Therefore, the concentration of hydrogen here is 0.002 mole per dm cube. Yes, what is the trick? The trick is to take it to standard form. And in standard form, that should be 2 times 10 raised to power minus 123 minus 3. This is hydrogen ion in standard form. And therefore, if you have hydrogen ion in standard form, this is like A times 10 raised to power minus n. Yes, so this is your hydrogen ion. I'm liking it. If you liking it, this is A times 10 raised to power minus n. Okay, therefore, we come here. If you have that standard form, we have that in standard form. So if pH is that in standard form, or hydrogen ion is this in standard form, therefore from the shortcut, instead of using this logarithm, from the shortcut, we can say that pH is n minus log A, n minus log A, without a calculator. So we only have to know log 1 to 9. So pH is therefore equals to, what's n? N is N is going to be 3, liking it 3 minus log 2. 3 so therefore pH is equals to 3 minus what's log 2? 0.301. So therefore pH is equal to 3.00 minus 0.301. So therefore I have pardon, we have something like this. So I have 2 here, here is 9, here is 9, here is 10. So 10 minus 1 is 9, 9 minus 0 is 9, 9 minus 3 is 6, then 2 minus 0 is 2. So therefore pH is 2.669. I'm just doing simple calculation, very simple calculation. Therefore the pH is equals to 2.669 units. As simple as that. Very simple, without a calculator. The only thing we have to know is to know the pH or know the logarithm of 1 to 9. And don't forget, very important, for instance, how would I call it? Like say numbers that are above 10, numbers that are above 9. Don't forget log AB is equals to log. When you have a very large number, try to divide it, try to break it down into 2 or 3 of these numbers. So for instance, I have log 12. Log 12, I know by now that log 12 is something as log 4 times 3. So which is something as log 3 plus log 4. Yeah, so stuff like that. Stuff like that. So try more, try more. I'll do one more before we wrap the video up. I'll do one more before I wrap the video up. And this one will be a little bit tricky and it's a UTME pass question. UTME pass question, please look at it before I wrap it. It's a UTME pass question. I'm going to do this one. Before we go, I'm going to do this one before we go. I know it has to do with 0.001 solution of sodium hydroxide. Yes, sodium hydroxide 2008, question 18. Exam question, UTM question, standard question 18. So the question says, all right, um, the question says, uh, the question says, the question, the question says, calculate the pH, calculate the pH of, calculate the pH of a 0.001 mole per dm cube of 0.001 mole per dm cube of NaOH solution. Now we have a base again. A base. They're asking us to calculate pH. So for this base, we already know we can calculate OH because the molecule has hydrogen ion. So therefore, quickly, what we have to quickly get is, normally solution first. pH is equal to negative logarithm of hydrogen ion to base 10. So pH is equal to negative logarithm of hydrogen ion to what class? Base 10. So and pOH is negative logarithm of hydroxy ion to base 10. This compound is a base. It can produce OH. What I mean is that NaOH does not have H ion. It has OH ion. OH ion. It has OH ion. So what do you do in this kind of case? Let me solve it here. Totally. Let me solve it. So in this kind of simple case, what we do is very real. We will have to first go and calculate the pOH. And not forgetting that pH plus pOH is equal to 13. So now let's quickly solve the first. Let's get the OH ion concentration. Remember the question says 0.001 mole per dm cube of NaOH. So how many OHs are there, or how many OH are there? It's 1. So therefore hydroxy ion concentration is therefore equal to 0.001 times 1, which is also equal to 0.001. As beautiful as that will sound, okay, remember, if OH ion is equal to A times 10 raised to power, what's it called, minus n. POH is equals to n minus log a. So first thing first. What is the hydroxy ion concentration? Hydroxy ion concentration, let's take it a little bit backward. Hydroxy ion concentration, OH ion concentration, pardon, OH. OH ion concentration is equal to 10, please watch, is equals to 0.001, which is the same thing as 1 times 10 raised to the power minus 3. So therefore, what's our POH? Our POH is equal to, what's N? This is A times 10 raised to the power minus N. Okay, since that my N is 3, so therefore POH is therefore equal to 3 minus log 1. Now, what's log 1? Log 1 is 0. So therefore POH is equals to 3. Then what is pH? pH is therefore equals to 14 minus 3, which will be 11. Now, I want to quickly, the answer is 11, but I want to quickly comment on something. Anytime the standard form ends on 1, 0.00001, and anytime the OH ion concentration ends in 1, or the hydrogen ion concentration ends in 1, therefore the POH or pH will just be counting the zeros. So counting 3 zeros is 3. That's 3. That's very simple like that. So even if you don't want to do it like that, you can follow. Just know that log 1 is 0. So you are going to have, put it in standard form, is 1 times 10 to the minus 3. So 3 at the back minus log A which is 1, A which is 1, log 1 is 0, still get 3. Then after getting the POH, pH is equal to 14 minus POH. Remember they're asking us for pH, not POH. So we can only get POH from the concentration given, because it is a base, it will have OH, it does not have hydrogen ions. So therefore, pH is equals to 14 minus POH, which is 3. 11. So I'll solve one more. This should have been the last, but let me solve one more. Okay, so you see, now you see a question like this. This has also come as the UCMS examination. Now calculate the pH of a 0.001 mole of a solution. That's the word. Calculate the pH of a solution with hydrogen ion concentration of 0.001 mole per dm³. So how do you do this? Solution? I said anytime you have the hydrogen ion to be a decimal place, and the decimal, the first significant value is 1. Then 0.001, 0.1, 0.001. So just count the number of zeros, that's the pH. That's when the first significant value in the hydrogen ion concentration is 1. A 0.001, 0.00002, 1. Anytime it ends in 1. But if you don't want to do it like that, we can also say, remember the hydrogen ion concentration is equal to 0.001. Now let's convert it to standard form. That's 1 times 10 raised to the power minus 3 also, which is 8 times 10 raised to the power minus n. Therefore, remember pH is n minus log A. What is n? 3 minus log 1. Log 1 is 0, so therefore it is 3. pH is 3. Ladies and gentlemen, I know this video has been helpful. Try to calculate pH without a calculator. So what you do is that you give the video a like, please. And drop your comments in the comment section. Ask questions in the comment section. And if you want any other question you want me to solve, I can do that and drop it on YouTube. Make sure you subscribe to this channel. Share with your friends. The exams are close. So until the next video, it's a bye. I'll see you and remain the Analogous. God bless you.